And therefore in this video I'll talk about a bipolar junction transistor first. Okay, so let's start. I actually refer to this video. If you want, you can just watch this, or nonetheless I'll go through in this video. Alright, and more things coming out alongside. Alright, so you have a power supply. Where's my pen? You have a power supply over here. Alright, you always go through here, and up to here this is an open circuit. Alright, this is like an open circuit. The only way for this to be closed circuit is when this thing is closed circuit. So if this thing is closed circuit, alright, then you allow the voltage over here to flow through. Otherwise you'll just stuck here waiting for this circuit to close. Alright, so I repeat again. If this is open circuit over here, alright, this is open circuit, alright, although there is voltage supplying through here, but up till here, at this particular point, this is a open circuit also. Alright, this is a transistor. Okay, until when you close this circuit, alright, you close this circuit, then you actually, for some reason, alright, you actually close the circuit. Alright, this is how the material within the NPN works lah. Alright, so once you close the circuit, the power will actually flow through this system. Alright, although there will be power flowing through this system, but you need it to be grounded first. Alright, so this thing go all the way to ground. So because this is minus, this is plus. Alright, this is plus also. This is minus. Alright, so if you have only plus, you will not supply anything to the LED, for example. Okay, so therefore you need a ground to actually ground it so that you can have this LED working. Alright, so I hope that this is pretty clear and does explain to you the reason behind NPN. Alright, so as you can see, if you were to close this thing, right, this is somewhat like your Arduino. Okay, and this is somewhat coming from maybe some other power supply. You can be within the same system, but in fact Arduino itself cannot supply such of a big voltages. So therefore normally I believe we may have its own power supply over here. Alright, that is not within this picture. Alright, there is some power supply coming from somewhere else plus. Okay, so the Arduino itself will actually supply its own power. Alright, we call this the base current. Alright, normally it's I actually call this the base voltage, 0.7 volts. Alright, so in order to allow the supply to actually flow through, alright, or to open the gate so that your voltage can actually flow through, okay, you require 0.7 volts. So once you supply a 0.7 volts to this point, you actually close circuit, allowing all the voltage to flow through over here to your whatever load that you want. So this is your load, alright, or to your machine or to your motor. Okay, so I hope that this is pretty a bit clear, I guess. So you may wonder, then what about the LED? The LED actually is not the load at all. Okay, so I shouldn't have said the LED. But anyway, the LED isn't the load. Alright, the load by right should be this place, your ground. Alright, so the supply will actually go through here up to this point. If your this thing over here is a open circuit, alright, then you're just stuck here. Alright, because this whole transistor, this whole system over here is a transistor. So if you do not have enough base voltage, you'll just keep on stuck here. Alright, until when you close this thing, or you close circuit, then you'll start to flow through into your load. Alright, then your motor will turn. Alright, for example. Okay, so I hope this is pretty clear. And this method of doing things is called the NPN. Okay, PNP on the other hand is a slightly different thing, but works as the same thing. Your base current is still gonna so-called control everything, but in this case, alright, this is going in this direction. Alright, this is the plus, this is the minus. Alright, and this is the plus. Over here the base current is actually plus, minus, plus, right? So as you can just somewhat compare. So over here your Yeah, I think you get what I mean already lah. Okay, and I think this one is a minus. Okay, wait, I think this one is a minus. Okay, so in the NPN, alright, your base and your this C is called your collector. Alright, this E is your emitter. Alright, where this one is your base lah. Happen that you don't know, because I assume that you already know. So therefore, for the NPN, the base and the collector, the B and the C are positive, while over at the PNP side, the B and the C are the negative side. Okay, so this is something that you may need to understand. But how the flow wise, I somewhat don't understand much. Alright, you can just watch the video if you want to know more, but I don't think it's related to our syllabus so far. Anyway, so the current will actually flow through here up to a point where this point, if your current over here, or I think it's more on comparing the current over here. Alright, so if this current is lesser than your base current, alright, you will not flow through here. Alright, so if your base current over here is smaller than your this current over here, then you'll flow through here and you'll go through your load. Okay, so this is another way of allowing your load over here to receive voltages or current. But the end in mind is that your base current over here, or the base voltage is 0.7 volt. The current, I don't know, it all depends on how, because if you remember V is equals to IR, it depends on your resistors and it depends on what current you want to input. Alright, but in any of the case, your base over here is from your Arduino. Alright, while you have another power supply. I should erase this line, so in case this may actually confuse you. That's what I think I may be wrong, but I would assume that there will be a larger supply over here. Alright, there will be a larger supply to actually supply a larger power. Alright, that is stuck over here. And upon you close this circuit, you close this switch, you allow the bigger current to actually flow through and eventually run your motor or your load or whatever. Alright, so this is one method to actually drive an external load, or a load that requires a lot of currents. Alright, so therefore this method is acting like a gate, or your base current is like acting like a gate. So once you reach a certain voltage, you'll close the switch and you open the gate to allow the supply to flow through here. Alright, same thing over here. You apply a certain if your applied base current or voltage is larger than this applied one, alright, you'll just keep there. And along, if happen that your base is lesser than the emitter one, then this thing will actually flow through, I think. I don't know. Yeah, this part are a bit blur lah. But anyway, I don't think we can go into the details, but at least you get a sense of it. And therefore this what I've been talking on is this page NPN, alright, 0.7 volt for your base. Alright, while the current, I don't know, you need to also go and calculate. It depends on your beta. Beta is equals to 50 for a medium power transistor. Alright, just take note lah. Okay, and so over here, this is your output from your Arduino, your microcontroller. Alright, so you're gonna output a base. So if your base is 0.7 volt, alright, then the VCC over here will actually somewhat go past. Okay, and then you'll go to the ground, and the whole load will actually. So in fact, the load over here is the load over here, that in my picture. So the LED is actually the load. Damn it. But anyway, at least I learned something lah. Okay. But in any of the case, you'll still allow the load to pass through. Alright, if you have a supply of 0.7 volt. Okay. So the key information is that if you supply a 0.7 volt, the base, you'll close the circuit and you allow the VCC to actually flow through and allow the load to work. Alright, that's the meaning of that lah. Okay, and the voltage for the collector and the emitter is 0.2 volt. Alright, and I don't know why is it 0.2 volt. Yeah, and also just to take note, your NPN, alright, MP is in fact a diode, alright, so it's like a LED style. But if you were to connect two diodes together, MP and PN together, you have an MPN system, which is what we are doing now. Alright, so MPN is a two diode system. Okay, happen that you forget or whatever. I just want to inform over here before I go on to other stuff. So the key issue is that the collector of the transistor is at about 0.2 volt and the base is at about 0.7 volt when the transistor is switched on. In order to switch the transistor on, you need a base current of 0.7 volt and a collector, you need a voltage of 0.7 volt and a collector voltage of 0.2 volt. Alright, so these are the two conditions that you need to understand. Alright, so I think this is it for this first part. Alright, so what I've been talking on is about only the single bipolar junction transistor. Alright, so this is exceptionally for normal load, alright, for normal large load. Still a large load, but it's a normal, not very large load. So in the next video, we'll talk about dilating pair, which is talking about a way to actually run a larger load, or a super large load. Alright, then you can use the dilatance pair. I shall see you in the next video.